Hello everyone. In previous videos, we have seen the Euler's method to solve first order ordinary differential equation and the example on Euler's method. And then after we have seen the Euler's modified method. And now it's time to discuss an example on Euler's modified method. Okay? That means the modified Euler's method. Here is the question. Using modified Euler's method, find an approximate value of y when x is equal to 0.3. Given that the differential equation is in this form, that means dy by dx is equal to x plus y and y is equal to 1 when x is equal to 0. That means the initial values of x and y are given, that's 0 and 1 correspondingly. Okay, we have seen this differential equation exactly by the example of Euler's method in previous videos. You can see it also. And in this video, we are going to solve same this differential equation using modified Euler's method. Now we started to solve that. Here we have to find the value of y when x is equal to 0.3. So that means we have the starting value of x is equal to 0 and we have to reach at the value of 0.3 of x. Okay. So that means we have the length of 0 to 0.3, that means the 0.3. So that means we have to divide this difference in 3 equal length. Okay, so we take here h is equal to 0.1 here. Okay, that's it, h is equal to 0.1 and then we use the Euler's method. Okay, so y1 is equal to y naught plus h and function of x naught plus x naught and y naught, that's the Euler's method. And then we substitute the corresponding values. So y naught, the initial value of y is equal to 1 here, and the corresponding values of x, that means the initial value of x is 0 here. So we substitute these values because this is given in this question. Okay, so initial value of x is 0 and initial value of y is 1. So we substitute these values here and then we get the y1 is equal to 1.1 by the use of Euler's method. Now here is the use of modified Euler's method. What's it? Modified Euler's method, we know that we have to find in modified Euler's method we have to find y1 more than one times. Okay, so y1 here first time, what's it? Y naught plus h by 2 and the summation of the functions at the initial values of x and y and the first values of x and y. Okay, so that means these values are here. uh, these values are x naught is 0, y naught is 1 and x1 is 0.1 because the first value of x is 0 and the h is 0.1. So here x1 is equal to 0.1, that means 0 plus 0.1. Okay, so that we substitute these values and then after x1 is equal to 0.1 and y1 is equal to y1, what we find here y1 is 1.1, so we substitute this value, then we find by this way y1 first time, so that is 1.11. Now we find the y2, then we find the y1 second time. Okay, so what's the y1 second time is? That's the same thing is y naught h function at x naught y naught and function at x1, and only thing is replaced here y1 first time in place of y1. Okay, so in place of y1 we put here y1 first time. Okay, so that's why its value is this. Okay, So this we can calculate it because the given differential equation is dy by dx is equal to x plus y. So that is the function. So in place of functions value we put always x plus y. Okay. So why this is okay, and then we calculate the values of y1 first time 1.11. Okay, then we find the value of y1 second time, that's it, 1.1105. Okay, then we see that the value of y1 first time is 1.11 and the value of y1 second time is 1.1105. That is not equal values. So we need to find the another value of y1, that means the value of y1 third time. Okay, so that's it. We write the formula for modified Euler's method. So third time we have to find y1, that means this in traditional way, and then we change only here in place of y1 we have to write y1 second time because we are going to find y1 third time. Okay, then we see here its value is just 1.1105. So that means these two values are same. That means the y1 second time and y1 third time both are same. So we not need to find the one another value of y1. That's the value of y1 in modified Euler's method. Okay, so that's the y1 is 1.1105. Okay, so that means the value of y when x is equal to 0.1 is this. Okay, now we go for the another value of y, that is y2. We know by Euler's method y2 is equal to y1 plus h into that function's value at x is equal to 1, x is equal to x1 and y is equal to y1. Okay, so then we substitute these values by previous one and then we find the value of y2 because x1 we know x1 is equal to 0.1 and y1 what we find is 1.1105. Okay, so then we substitute these values here and then we find finally y2 is equal to 1.2316. Okay, so that's y2. Now by Euler's modified method, what is, we have to find the y2 first time now. And what is the formula of Euler's modified method? We have to go to find the value of y2. So we have to use here y1 and here x1 y1, here x2 y2. Okay, so then we substitute the corresponding values and then we substitute these values and then we find 1.2426. Okay, that's the value of y2 first time. And then we go to find y2 second time. And what's the y2 second time is? Y2 second time is just there is y1 is same, h is same, function at x1 y1 is same and x2 is same, but in place of y2 what we put here y2 first time. Okay, that's value from here. Okay, and y2 first time we have already found it, so 1.2426 and that's we substitute here. Okay, here. Okay, so then we find the value of y2 second time. Now you see the value of y2 first time is this and value of y2 second time is this. That means these two are not equal values, so we need to find y2 third time and then you find the value y2 third time by putting the value of y2 here, y2 second time. Okay, in this. Okay, and then we find its value is total after calculating this, that's the total value is 1.2432. That means in this time there is the value of y2 second time and y2 third time both are same. Okay, so here both are same, the value of y2 second time. Similarly, you can find the value of y3 also by continuing this process. You'll get this value 1.4004. Okay, you may find it by the use of this similar process. Okay, so we have discussed today an example on modified Euler's method In the next video, we will discuss some another concept of mathematics. Okay.